Assalamu alaikum warahmatullahi wabarakatuh. Welcome to another tutorial video for our industrial automation course. Today we'll be discussing about PLC examples, and the example will cover basically a special problem for up counter, and also we will be discussing one example how to use mathematical expression and comparison in PLC. Okay, let us first look into the counter problem. So, let us see a particular problem for the case of counter. Let me enlarge it a little bit more. Okay, so here we are. So basically what we have here is basically a bottle counting system. So in this bottle counting system, these bottles are on the conveyor, and as each bottle passes through this true beam sensor, the counter counts one bottle at a time. Now it may happen that this bottle may, because it's a mechanical system, so because of the jerkiness of the conveyor belt, this bottle may shake, and when it shakes, it may same bottle may cause because of the shaking, the same bottle may cause multiple count through this sensor. So electronically, if we see this thing, let me minimize it. So if we see this thing electronically, you will have this high frequency noise input to the PLC. So we have to have a system that should ignore this high frequency noise, and then we can have a more smoother counting system. So basically what we can do here is, let me show you the example through our simulation software. So I have already made this PLC ladder diagram, and let me see the thing. Let me toggle the things first. Okay. So I hope we are good to go. Let me download this one. Okay, and then we put in run mode. Okay, now this is the case. For example, we have the sensor that is basically the counter for the bottles. Okay, it's a through beam sensor connected to the PLC. Now what we did previously in a conventional way is to connect this sensor directly to the counter, but instead this time what we did, we connected to a timer. Though for example purpose we have put this preset value very high, but this preset value should be low. For example, you may have a rough estimate that from one bottle to another bottle how much time it would take, maybe 2 seconds or 3 seconds. So then we can put here 3 seconds, but that will not serve my purpose here to demonstrate the simulation. So that's why I purposely put it here 60 seconds, almost like 1 minute. So what happened is that once this sensor is activated, basically the timing bit will be true, and this is doing a latch because once the sensor is activated, this latch will cause the timer to activate, and sensor, if it goes down and again go because of the shaking, it toggles back again, still the timer will not restart again because of this TT bit, and this TT bit will actually do this counting, not the sensor directly. So for example, for high frequency shaking, the sensor may toggle many times, but the timer will be held by this TT bit, so your timer will not be reset. Your timer will be reset only when the TT bit goes false after finished counting the timing. So let's see what happens. Let's toggle this. That means toggling means the sensor, it first detects the first bottle, and so we toggle the bit and see. So you can see, I don't know why it is not working. Let me toggle back again. Let me see what happens. something is causing it to have some problem. Let me see. Okay, it was force enable anyhow. So you can see now it is keep on ticking the timer, and then once let's say I toggle it back, so it is shaking, so we toggle it back, but still the timer is keep on ticking, and once tick it will count up. Okay, let's say it is now 4, and I toggle back, it is not changing. So I toggle back again because to simulate the shaking effect, and I toggle it back again, so it is not changing. As you can see, previously it has counted 3, now it is 4, so that's why it will only count again once this timing bit is finished. So now this is toggle back. So let's say if we go until 60, then we will see how it will count up. So 55, 56. Okay, so your timing is now become false. Now next bottle came into the sensor, and we toggle, and you can see here it becomes 5. So, and then we toggle back. Okay, so it will do after 60 seconds, next bottle will come, and then it will count again up. So once the counter done bit becomes true, that means your this accumulator will be equal to the preset value. Then basically, which is 10, the green light will be on. And to reset, you can press this button just to reset the counter accumulator value. If you press it in the middle of the counting, also it will basically will reset the value 0. So you have to, it's a push button, so you toggle it back. So this is how the system works. Once the TT bit is true, then only it will count. Now just for your info, that the PLC, Allen Bradley PLC, also supports mathematical expression, for example, addition, subtraction, multiplication, and all those things, similar to normal programming. Similarly, it also supports comparison, like less than equals to, greater than equals to, limit test. All these things are supported. So I want to show you this use of the addition block and comparison block. So we want to simulate similar process of counting up, but instead of the counter, we want to use addition block. So here is the example where we are using add function. So basically we have a sensor that is used to detect the bottles, same sensor, I mean different address we have put here, similar sensor. And remember, this addition block, all these mathematical operations should be on the output side, and the comparison is on the input side. So what happened here is basically the sensor will be used to add two numbers. So the first source A and source B, and we will, after addition, we will put it in the destination. So this is how the system works. So source A is basically a memory address or any number. So the memory address is for integer, we put it N7 colon 1. So this is the memory address for syntax for integer. And then in the source B, we did not put any particular memory address, rather we put a constant value of 1, increment value of 1, and once it is added then the addition will go into the destination. As you can see, the destination is same as the source A. So that means what it does is basically it will just keep on increasing the value with an increment of 1. So once the sensor is activated through the new bottle, then it will count 1. And then I will come to this point later on. And once this value of N71 is greater than or equals to 3, that I just put it here 3 so that we can do it quickly, then basically your this green light will be on. So once this value is increasing and then it comes to whatever value you would like to compare, then the green light will be on. So this is basically greater than or equals to. We have less than equals to as well. We have just equals to. We have greater than. We have less than, and we also have limit test. That means the range. So now, what is the purpose of this OSR? OSR is called one shot rising edge. So one shot rising edge means when the sensor goes from 0 to 1, then only this thing will be counted. Otherwise, what will happen is, because it is true, it will just keep on adding. So we don't want that. We want only when the sensor is moving from false to true. Counter automatically takes that into consideration, but addition block, you have to have this one shot register in series to ensure this is basically a memory address when you put one shot register B300, and this one shot register means it is ensuring that once only it is going from falling edge to the rising edge, this sensor, then only it will count up. So let's see what happens. So let's say first bottle comes, so this will become true, so we toggle the bit, so it goes up by 1, you can see here, and this also become 1 here. So then we untoggle it, so next bottle is coming in, so we toggle it back, so then it goes 2, and here also you can see it goes 2, and green light is still turned off, and then we toggle it back, so new bottle is coming in, so and then you can see it becomes 3, and this is 3, so they are both equals 3, so that's why your green light is now on. So we toggle it back, so this is the case. So now you can see here that we can use this addition and greater than equals to block to do the same thing as like the counter. So in the next lecture we will discuss more complicated examples regarding mathematical expression and also the comparison expression in PLC. Thank you very much. Assalamu alaikum warahmatullahi wabarakatuh.